Alright, this is lesson 46 for 8th grade, and today we're talking about some scientific notation, which scientific notation is review, but we're going to do something different with it today. So we'll take a look at and go back to what scientific notation is, and then kind of put a new spin on it. So just a reminder here, in order for a number to be in scientific notation, the first number must be 1 or greater and less than 10. And then we're going to multiply it by a power of 10. So here are some correct examples. 2.3 times 10 to the 5th. 4.51 times 10 to the 4th. 2.08 times 10 to the 7th. Notice how all the first numbers are greater than 1 and less than 10. Okay? That has to be 1 or greater. So another acceptable one could be 1 times 10 to the 6th. Okay. So it can be 1 or greater, but it has to be less than 10. So we're basically looking for, this first number has to be 1 or anything less than 10. So 1 or greater or anything less than 10. So here are some incorrect examples. 23 times 10 to the 4th. This is a number, yes. It comes out to a standard form, but it is not in correct scientific notation. Actually, this number and this number are the same, except for this is the correct scientific notation, this is incorrect for scientific notation. Same with our second example. This number and this number, if you went out and did the multiplication, they would come out to the same answer. However, they are not, or this one is not in scientific notation, this one is in scientific notation. And lastly, these two numbers come out the same if you do the multiplication, but this one is not in correct scientific notation, this one is. So let's just look at those numbers and make sure we remember. Remember this exponent, when multiplied by power of 10, it just moves our decimal to the right, as long as this is positive, and we'll get into the negatives later. So this is 2.3. We're going to move our decimal 5 spots to the right. 1, 2, 3, 4, 5. And any space that we have, we fill with a 0. So this number is 230,000 in standard form. Okay? Now this one I said should come out and equal that one too, even though this is correct scientific notation, this one is not. But this is 23, and our decimal is right here, 23.0, another way to write it. Move it 4 spots. 1, 2, 3, 4. Okay? Still get the same answer, 230,000, but once again, correct scientific notation, incorrect scientific notation, even though they're the same number. Okay? And just to go back and say why we use this, a lot of times we have numbers that are very large or very small. So we use scientific notation to represent them, so we don't have to be writing all sorts of digits over and over again. So if I move this decimal 4 spots over, it would get 1, 2, 3, 4. 45,100. We would still we should get the same answer here. So 1, 2, 3. We still get the same answer either way. But once again, one is correct scientific notation, the other one is not. Alright. And we'll show you why those still came out to the same answer on some examples coming up. Alright. So, to multiply numbers written in scientific notation, we will multiply the coefficients to find the coefficient of the product. Then we will multiply the powers of 10 by adding the exponents. So, taking this example, this is 1.2 times 10 to the 6th times 4 times 10 to the 8th. Okay? And what they do is they're going to multiply the coefficients, or the numbers first, 1.2 and 4. We're going to multiply those together. And then we're going to group our tens. 10 times 6 times 10 to the 8th. And what they do is they add 6 and 8, because this means 10 sixes or 6 tens multiplied times 8 tens, and we'd have a total of 14 of them. Our shortcut says if this base and this base are the same, we can add our exponents so we get 10 to the 14. 1.2 times 4 is 4.8. So this is written in scientific notation. This number is less than 10, but it's greater than 1, and we're multiplied by a power of 10. So we're good. That one is simplified. If the product is not in proper form of scientific notation, we revise the product so that there is one digit to the left of the decimal point. So that's where this is going to come into play. So we start off with a problem just like we did last time. 7.5 times 10 to the 4th times 2 times 10 to the third. And what we're going to do is multiply our numbers first. 7.5 times 2 is 15, or 15.0, same thing. And then we're going to do our tens here. 10 to the 4th times 10 to the third. We can add those together. 10 to the 7th. Now, it is simplified, but it's in the incorrect form because it's not in scientific notation. So we want to observe the last 3 steps, okay? What we want this in scientific notation, which means we want this number to be less than 10, okay? But we also want it to be 1 or greater. Well, if we move this over 1, we get 1.5, okay? Now when we move it back 1, we need to multiply it by an extra 10, so that in the end, so remember when we were looking at that first screen, we had an incorrect form and a correct form, even though they still came out to the same number. So 15.0 times 10 to the 7th equals 1, 2, 3, 4, 5, 6, 7. So we'll get this and this. 150 million. However, if we move this thing back to 1.5, we have one more extra to move over, right? So we need to do this times 10 to the 8th. And the reason is because 1.5 times 10 to the 7th wouldn't give us the same number, but 1.5 times 10 to the 8th would. So if we move it back this way, that means we have one more to carry over this way for the next time. So this equals, if I go 8, 1.5, 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 0, 0. And we should get the same answer now. And we do. 150 million again, okay? So, we have to be careful when we get what we think is a simplified answer, which it is, but we want it in scientific notation. So we have to move this back, that adds 1 to our exponent, because in the end, we would have to move it over one extra 10 spot in order to get the same answer. So hopefully that's making sense. We'll look at it more tomorrow. It is a little different. Okay. And the way that they explain it is that when you move this over, 1.5 times 10 to the first is another way to write 15. Okay. So this right here is actually 15. Okay. Because 1.5 times 10 equals 15, but if you're adding a 10 and multiplying it, you have to add 1 plus 7. That's where they get 10 to the 8th from. So we'll kind of use that format when we look at some examples. Okay. Just want to see. Okay. Find each product. 1.2 times 10 to the 5th times 3.0 times 10 to the 5th. So 1.2, we want to get our numbers together first, coefficients, 1.2 times 3.0, and then multiply that by 10 to the 5th times 10 to the 5th. Okay, so 1.2 times 3.0, I want to do that first. So should be what, 36 or 3.6? No, yeah, 6 and 3. So 3.6 times 10, and then we add 5 plus 5. Okay, now that one is in simplified form, that is in scientific notation. This number is less than 10, greater than 1, and times the power of 10. Now let's look at this one. We've got 4.0 times 10 to the 4th times 5.0 times 10 to the 5th. So we multiply 4.0 times 5.0 and 10 to the 4th times 10 to the 5th. Okay, so this is 4 times 5, which is 20.0 times 10 to the 9th. We add 4 and 5. However, now we have one that is not in correct scientific notation. 20 is bigger than 10, so we have to move this decimal back 1. But if we move it back 1, we have to add a power here, because 20 is also equal to 2 times 10, and we're also multiplying it times 10 to the 9th. Okay? That's the way the book explains it. So this is actually 2.0 times 10 to the 10th. Alright? Alright. Check my time quick. We're getting there. So if we run out of time, we'll cover the rest tomorrow in class. Alright, remembering our laws of exponents, let's try to figure out what to do when dividing with scientific notation. Okay, so this is our last slide here. Same deal. We're going to divide 1.44 times 1.2, and then instead when we multiply we would add our exponents, but now we're dividing. And if we have the same base, we can just subtract the exponents when we divide. So we're going to have something times 10 to the 12 minus 8, which is 4. 1.4 divided by 1.2, I believe is just 1.2. Or 1.44, sorry. Alright. Well, let's make sure that's correct. It is. And that one's in good form. Okay? This one is in scientific notation form. Sorry, I had to double check that. I had a little mind cloud there. Alright, 3 divided by 4, this is going to be a number less than 1. 3/4 basically is 0.75. And then we subtract 8 and 4. Times 10 to the 4. Now this one's a little different. So before, on the ones we were talking about, we were getting numbers bigger than 10. Now we have one that's less than 1. And we want to get this thing to be 7.5. Okay? So we want to move this over so that it's between the 7 and the 5. Okay? Before we added to the exponent, now we're going to take away from it 10 to the 3rd. Okay? If we did 0.75 times 10 to the 4th, you would get the same answer as if you did 7.5 times 10 to the 3rd. We are taking our decimal and shifting it over 1. So basically we're taking one of those tens away when we do that. as before when we were adding a 10 to it. Okay, so it's a little backwards, but we'll talk about that more in depth tomorrow. And I'll see if I have time for that last one. We're over anyway, so we might as well just do it. 7.5 divided by 2.5, and it's 10 to the 6th, 10 to the 6th. Now, if we do, okay, let's do 7.5 divided by 2.5, that should be 3.0 times 10 to the 6 minus 6 is 0. Anything to the 0 power is 1, so it's really 3.0 times 1. We get 3.0, or just 3. Alright, we'll definitely cover more of this tomorrow. It's definitely kind of an interesting topic when we look at it this way. So we'll jump into this and kind of spend some more time on it. Thanks.